Start the recording and let's go. Come on, guys. In this video, I will try use my English to explain for you uh, how to solve this problem path with minimum effort. Okay, I not solved the problem yet. Then let's check. Uh, you are hiking, prepare for an upcoming hiking. Yes. You will get one matrix with height. Then the answer is the minimum effort in the path. The effort is the maximum absolute difference in height between two consecutive cells in the root. Okay. In the first example, in the path, the maximum difference is 2, 3, 4, 5, and 5, 4, 3. If you try make the path for upside, the difference between 2 and 5 is equal to 3. Okay, it's a pretty simple problem. How I can do this? It's a pretty common problem. In this problem, I have to check the first difference that that is possible to reach the final point. Then I will use one binary search to find the point in log n time, and for each search is a simple BFS. Start in the first place, trying reach the final place, but I will make a movie only if the difference is at most one difference. Okay, let's go. I have the heights. I will have the left in the binary equal to 0, and the height is the maximum difference that is possible I have in the program. Let's check the constants. At most, I will moving from the 1 to the 10 power 6. Then the maximum difference is the difference 1, 2, 3, 1, 2, 3. Okay, for each binary search, while left is less than right, I will search in the middle. The middle is equal to left plus right divided by 2, and after that, after the search, the left will be equal to right, then return left or right. Okay, if possible, to reach the final point, I will pass height and the maximum value equal to m. If I can reach using m, the answer is m or less. Then I need to decrease right side equal to m. Otherwise, the answer is m plus 1 to right. Then L is equal to m plus 1. Okay, I only made this possible. Possible is one boolean, and this possible will receive this height and the maximum value mx. Okay, for the problem I will need one one structure to store if I reach or not. Then I will call this mask. The length is equal to the same of the height. Then the column is equal height dot size, and the rows is equal to height dot size, and the column is the height 0 dot size. Okay, the column height 0, the rows right. Yes, let's go. Let's continue, and let's make the mask was in the same size. Is one mask of boolean. Okay, vector of vector boolean with size or, and each vector of vector boolean will be equal to vector of boolean with size c, and all elements will be equal to false. Initially, I don't reach any point. Only point is the mask 0, 0, because 0, 0 is the initial point, is equal to true. Yes, for try make this, I will need one query of pairs, because in the query I will store the points, the location. Each location in the matrix is 2 pointers, one column and one row. I will call this BFS. Okay, initially BFS the push for the initial point, the 0, 0. Okay, it's pretty simple. And the final return the mask of the final point. True if I can read them, false otherwise. Okay, final point is mask or -1, C -1. Okay, then I will try make this search while bfs.size. Let's go. The position I will call I is equal to bfs dot front, because it's a query, dot first is the column, no, is the row, and the second is the column. Okay, after get the column and row, let's pop off. Okay, and each position I have 4 directions. Let's try write this direction here. I have 1 directions in the row and 1 directions and the column. I have 4 directions in the rows, 4 directions in the column. Let's go make these directions. In one direction, I will maintain row and move positive column. The second, maintain row and move negative in the column. The third, move positive in the row and maintain column. And the last one, move negative in the row and maintain column. Yes. This is all directions I need. Then let's go. For each one of these directions, 0, then less than 4, d plus plus. For each directions, I will have one new position. Int I is equal to I plus direction row d. Make the same with gg. Gg is new column, and II is new row. If the position is inside the grid, II need to more greater than or equal to 0, and II need to be less than or, and JJ is greater than equal to 0, and JJ is less than C. Okay. If all pointers is all constraints are true, and I not visit the point yet. I not visit checking the mask. JJ is equal to false. Okay, if I not visit, oh my god, I need to check the absolute difference. I need to check if the absolute difference between this element is at least ms. And check, look, ABS of heights I, J means heights I, J, J. The difference is at least smaller or equal to ms. The difference is at least this. Then make the new position equal to true. Okay. And put the element inside. Put the element inside in the BFS. Okay. In the BFS dot push, new element is equal to II. JJ. Okay, it's okay. Run code to check. Not correct. Not correct yet. Let's check. It's okay. Check M. This looks correct. Okay. Let's check this. Let's get one overview. Or is the correct? C is the correct. Directions are correct. Mask of bool elements are correct, are false. The initial element is equal to true. Okay. Let's check again if the difference between the initially position to the next position if the difference is less to max. Let's make the movement. Okay. Okay. Don't look wrong. Okay, let's check this. I have if is possible, if is possible, using m. The answer will be equal to m to left. Okay. If not, I will try using the difference, and it's not possible to get. Oh my gosh. Okay. Okay. Pity, it's okay. Um, let's print chef on the book here, the book. Let's print the L, the R, and the answer. L, R, and the answer is possible. Okay. Okay, let's check. It's okay, it's okay, it's okay, it's okay. I will try with the 5, and 5 is getting wrong. With 5, my BFS return that is impossible to reach the final position with at most 5. Then let's check. It's something wrong here. Let's check. Our position, our directions is okay. True. Okay. BFS dot size. Okay. From dot first, second row. Oh my gosh. I don't change. The first is direction in row. The second is directions using columns directions. Run code again. Probably is correct here. Now it's okay to let's drop out the book code, and let's go. Okay, let's submit. One letter, guy. One letter. It's accept. More details. Oh my gosh, it's not too good. Only 50%. Let's make one pretty simple change. If I reach the final position, if II is equal to R minus 1 and GG is equal to C minus 1, return true. If I reach all numbers, all positions, return false. Let's try again, submit, and check. Oh my gosh. Oh my gosh, if I am in the tree, let's return R-1, C-1. Run code, and it's okay. Submit. Yes, accepted. Let's check again. Yes, one line made more faster. This line here. If I reach the final point, return. Okay, if I reach the final point, okay, it's better solution. It's a good solution. Let's try. Make the same, but more with more lines of code. That's okay. It's a pretty good solution. Okay, guys, it's all for today. Let's finish the recording. Thanks for watching and peace. Come on.